idea now is to talk about convex hull, the idea of Grahm scan to create the convex hull. We will talk about this method. The idea is to create the convex hull that encompose all the points in the convex hull. As you can see, this is an animation from Wikipedia which shows us one version of the Grahm scan, which the idea is that from each point we want only to move to the left. If there is any point that causes us to move to the right, like here, what we are doing, we are taking out this point, like this one, and going back, and then trying another one and check if using this, we can move to the left here. So we can see here, this is the left, this is right, so we moved it and continue here. This also moved to the right from here to here, so we abandon this, get back to this one and go there. Here right, so we abandoned, here right, we abandoned. So you can see that every time we are trying to go to the right, like this, we abandon the point, going back and trying again until we get the convex hull. Again, going left, going right, not good. Going right, not good. Going back. Going right, not good. Going back. Going right, like this, not good. Going back. Going right, 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 not good. Going back. So you can see here the idea that we are moving only to the left here. If we are making any right turn and not left turn, we need to go to the back, go to back, back, back until we are making only left turns here. There are different versions. Sometimes we are going in the upper part and then in the lower part. And in the upper part, we just want to go to the, for example, to the right and not left turns. And in the down side, we can only go to left turns and no right turns. Here you can see the idea in one piece. We're doing all the convex hull by going only to the left, and every right turn we are discarding the last point, going back and then trying again. If it's not working, we're discarding the point, going back and trying again. Every time we're making right turn, we discard the point that make us go to the right and try another time. We are starting with the, as you can see, the lowest point here in regard to the y direction, and then we start by going left, only left turns in this direction, this right direction. And you can see again, every time we are making a right direction, we discard the last point, going back, and if still we are doing right direction move, we are discarding the point and going back and try from the previous point until we are only moving here to the left. Again, there are different versions. This is one version of the Grahm scan, and you can see how it finds, as it should, the convex hull. It's about, if I remember correctly, n log n in complexity. Let's see if they are here. Here it is. Yes, sorting the points is time complexity of n log n. We're starting with sorting the points to take the lowest point. And you can see here how they are calculating if it is a right or left turn. If there is only collinear, if positive, the 3 point goes to a left turn, or counterclockwise, otherwise right turn. What they do is calculating x2 minus x1 times y3 minus 1 y1 minus this value, and if the result is 0, they are collinear. If positive, it's a left turn, and we want, for example, here left turn, or counterclockwise orientation, otherwise it's a right turn. Okay. Find the lowest y coordinate and leftmost point. This is the idea we are finding here. We're going to the most lower in the y direction and the leftmost in the y. If we have 2 points that are mostly lowest in the y direction, we're going to the leftmost one. This is how we start, and you can see there the pseudocode for this idea using stack and everything. Okay. But the idea I wish is quite So this was about the Gram scan. Thank you very much. If there are any correction or mistakes, please tell me. And this is one version of the Gram scan, and that's it. And I didn't show you the time complexity. I'm not sure what is the time complexity getting at the end. It is actually because of point on each point. Okay, I'm not sure. The overall time complexity, yes, I remember correctly. O and log n, yes. Okay, that's it. Thank you very much. That's it.